Hey everyone, we're going to go through conditional probability today for Year 10 Maths, and we've just had a look at the addition rule in our last class. And just quickly, for conditional probability, you can use logic. You can use logic to do a lot of this stuff. So I'm going to go through. There's a formula that you can use, but I'm going to say that the formula isn't really necessary. Really isn't necessary for conditional probability. Let me just quickly talk about it, and I've got my wonderful Year 10 class in here that are going to follow through this with me and hopefully answer some questions and things. But the first thing we're going to be doing is when we're looking at whenever I see the word, or we're thinking conditional probability, whenever we're thinking conditional probability, we want to be thinking about we've got a condition, and in particular, this whole word, we're looking for the word given a lot of the time. We're looking for the word given because consider an event diagram displaying the number of events. Find the probability. Now, what does this mean? Probability of A, and there's a little line there. This means that it's the probability of A given B. Okay, and this one over here is the probability of B given A, and they're not the same. They're not the same. So let's have a look. So let's write this down here just quickly. This here is the probability. This is the probability of A given B. Now, usually in the context of a question, it might be, what is the probability that it is a four-wheel drive given that it's a sports car? Or likewise, what's the probability that it's a sports car considering it's a four-wheel drive? So there's conditions, and they are not the same going both ways. So this is the probability of B given A. Okay, so this little line here is representing the term given, which sort of represents probability. Now, if I was just to talk about this, and let's highlight this in the Venn diagram, if I was to, and I might do it in blue, you can see here that how many things are B? How many things are B? How many things are B? Denzel? 6. So there's 6. You can see there that this is A and B, and this is B, isn't it? So we've got 6 things which are B. How many of those are A?
7.
So how many of those things? Sorry. So there's 7 things that are A. You're absolutely right. But of those, so we notice that with the probability of A, given that it's B. So we've been told that it's B. So if we're told that it's B, then we're just looking there, aren't we? Okay. So if we're just looking there, the probability of A given B, the probability of A given B is, well, we've got 3 favourable outcomes which are A, and that's out of how many? 6. Now, of course, we can simplify 3, 6 to divide by 3. Divide by 3 is of course 1/2. And we could also ask you then, what's the probability of B given A? Well, this time A is the 3 and the 4, which is 7. So we've been given 7, so it's out of 7, isn't it? How many of those are B? We can shout it out. How many are B? 3. So 3 out of 7, the probability of B given A is clearly not the probability of A given B. It could be, but they are 2 separate things. Now, as it turns out, what could we talk about as far as the thing? Now, in both of these cases, the intersection has been common, hasn't it? This 3 here. So what could we do is if by the way, if I've got the probability of A given B, and we had 3 out of 6, didn't we? We had the intersection. That's the would you agree that's the probability of A and B? That's this thing. Okay. And what will we divide it? What do you think we're dividing it by? if that's the probability of A given B, well, here, this is the cardinal number of things in B, isn't it? There were 6 things, so it's 3 out of 6, wasn't it? So in actual fact, the probability of A given B can be expressed as this. This is our formula. But would you agree that our formula is not really that necessary if you had a Venn diagram? Because we know that the probability of A and B, well, we've got 3 things. It might even be better to use the cardinal number. You can use the cardinal number. Okay, A and B is equal to the number of things in B. Okay, because if you're doing probabilities, you tend to be looking at fractions and things. So you can do that. Okay. Now let's. So this is going to get us to our formula, and that is if we have. Well, we'll get to the formula in a second. But before we do that, let's have a look. You tell me. We've got students that that have chosen maths on the left. We've got students that have chosen biology on the right. We've got students that have selected both. What is the probability that a randomly chosen student has chosen maths, given that they have chosen biology? So if I'm looking at, first of all, how we're going to write this in with the right notation, what we want is the probability of M given B. That's what we're writing, okay? And the probability of M given B, well, we've been given that it's B. Is this B? No. Okay, so we don't want that. Is this B? No, it's not. So we're just looking out of here, aren't we? Okay, now the number of things in B, 13 plus 16, which is 29. And out of those, how many of those are A? Or, sorry, how many of those are M? 13. Okay, so we've got, now, again, let's have a look, because, again, we're going to then be introduced into a formula, and the formula is exactly what we've just done, the exercise we've just done on the Venn diagram. That is equal to the, let's call it that, we won't do the probability because the probability is going to be a fraction. Let's do the cardinal number, would be probably easier. That's going to be the number of things in M and B and the number of things in B. And of course, that's going to be 13 over 29, isn't it? Okay, 13 out of 29 is our answer. Okay. Now, this brings us to our rule. So essentially, that's what it is. If I want the probability of M given B, that is equal to the probability of M intersection B and the probability of B. So if you change that to A given B, then that would be A and B and the probability of B. Notice, what I think you want to notice though, is this. You want to notice that the thing here, the thing that we're given, that goes down here, okay? So A given B, you've still got the intersection of A and B. That's still going to be the same. And that's what I've talked about. That's what I've talked about here. The probability of A given B is the probability of A and B over the probability of B. The probability of B given A, though, B given A is over the probability of A. And you don't really even need the formulas if you're reading off a Venn diagram or something. It's probably easier to consider just what we did then, those two exercises. Okay, let's have a go at this. We've got event A, which is taking an ace from a pack of cards. We've got event B, which is selecting a black card. Can we, first of all, let's do a Venn diagram. And if you're watching this at home, feel free to pause and have a go. But let's try this now in class, and we'll go through our answers shortly. All right, so just for me to explain this is what we're looking at. So we have 4 aces in a deck, but two of those are black. 2 of those are not black, for a total of 4 black. We have 24 black cards, which are not aces. And of course, when we do all of that, we add it up and we're left with 24 cards, which are not aces and they're not black. To find the probability of A or B, I would just do, remember, it's given B. So I was looking out of 26. Okay. And of course, when I'm looking at a 26, that's actually technically, that's the number of things in B from the formula. Okay. And likewise, the number of things, the intersection always goes on top. Okay, so that's going to be 2 out of 26. But again, we could just go through and do that from a Venn diagram, but we can also use, so I've done this 2 different ways because we've used the formula for one, just the Venn diagram for the other. Note though that for probability of B given A, so that this time we've been given the left-hand side, and there's 4 things in there, but notice that that is the number of things in A. So B given A is not A given B. That's the main thing I want you to take away. And of course, 2/4 is a half. Okay, so that one's pretty straightforward. This time we've got a slightly different situation. We do still have A's and B's, but we've got hockey players, 15 hockey players altogether. So let's fill this out. With this time, different situation. We've got a 2-way table, and we've got 15 hockey players altogether. So let's write that in the bottom right-hand corner. We're dealing with a cardinal number here, so we'll deal with that. We can work out probabilities later. 13 played on the field. Now, by the way, A is the event that a player played on the field. So if 13 played on the field, then that means we're looking at this column down here, which is 13. Now, of course, if everything, we know that A and not A must add to the amount of players on the field altogether. So 13 plus 2 is 15. Likewise, it says 13 played on the field, 7 sat on the bench. Well, B is the event that a player sat on the bench. So that means that this row here, this top row is going to be 7, which means that how many did not sit on the bench? 8. Very good. So 8 did not sit on the bench. Now, the thing is that from here, we can't quite do anything yet until we look at the fact that 5 played both. Oh, 5 played both played and sat on the bench. So that would be A and B. Is that right? So A and B, 5 both played and sat on the bench. Well, both played is event A and sat on the bench is event B. You can play and still sit on the bench, can't you? So that would be 5 there. Now that we've done that, we can go ahead and fill out the rest of the table. 5 plus 8 is 13. 8 plus 0 is 8. And then, of course, we're looking for 5 plus 2 is 7, and 2 plus 0 is also 2. Okay, so we've done our 2-way table. Now it says find the. Now, by the whole point of this is, do you think we need this formula here? Do we have to use this formula? No. Is a 2-way table on a Venn diagram basically the same thing, just look a little bit different? Yeah. Yes. So that means if you can read it from a Venn diagram, you can also read it from a 2-way table without having to use some formula. Okay? Find the probability the person only sat on the bench. Well, the person that only sat on the bench that means that they didn't play on the field. That's the probability of A is they played on the field. So they did not play on the field and they sat on the bench. 2, isn't it? Okay, not A and B. Not A and B. That's going to be 2 out of 15. Only sat on the bench, so they didn't play on the field. Find the probability the person sat on the bench given. So the moment you see that word given, this should be a ding, 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 hint, hint, hint. That is conditional probability, isn't it? This, you will often see this word given. And the moment you see that, we want to be thinking that this is like given B. The condition is that it's B. So we're not looking at everything, we're just looking at the event B and then taking it out of that. So that's going to be now the probability of sat on the bench given that they played on the field. So that's going to be B given A, isn't it? Now we can look up here. B given A is not this formula on the bottom in the top right because that's probability of A given B. But remember, what have we talked about? That the thing on the bottom, the denominator, is always this thing here. So you can replace that with an A and you can use your formula. But again, I've got a two-way table here, so why would I need to do that? Let's have a look. What row or column will tell me the amount of things in A? The first one going down. Romans had these big columns, so the columns would go up and down. So if you're ever thinking about what's a column and what's a row, those big Roman columns. So okay, 13 things are A. Of those things which are A, because we're being given that it's A, how many are B? There you go. So what's the probability? 5 out of 13. I like that you had in a stab. It's okay if you get it wrong. It's all good. Now, find the probability the person played on the field given they sat on the bench. Is it the same as before? Probability of A given B. So this time we're looking for, well, B is this row here, isn't it? So given B, there are 7 things in B, aren't there? And how many of those are A? Still 5. 5 out of 7. That's right. And we've just done the question. Okay, so nothing too crazy about this stuff. Nothing too crazy. And again, you don't need to be scared by formulas because we've just done those without formulas. But by all means, use the formulas if they suit you. That is perfectly fine. But it's also good to understand. Now, what I'm going to do is if you're watching this at home, I'd like you to try this question. This is a sort of a test style question. And again, we're starting off with a Venn diagram and towards the end, we have got given. So feel free to try this at home. My class in here are going to try this right now. They're going to have a go at it. And we're going to go through and reveal our answers in about 5 minutes. But for you, if you're pausing, that'll probably be in about 5 seconds. Okay, so really important, and this is a really important thing. When you're doing a test, and if you botch the Venn diagram up, you will get some consequential marks for what you've done, but then it can be also difficult for me to establish what you've done as well. So really important to get the Venn diagram correct. And we've got 2 events. We've got N for new direction and R for rolling stones. And really important, N like both, but you've got to include the fact that if 25 like new direction, we need to subtract 10 from 25, which means we've got 15 that like new direction but don't like rolling stones. And we've got a total of 5 that like rolling stones. And since it all has to add 40, we're looking at what's that going to be? That's going to be 10 that don't like either. Now, it says here, now you don't need to do this, but it's also nice to know if we were to ask you in using set notation, that's going to be the probability of rolling stones or new direction. Okay, but if you don't need to write that right now because it's saying what is the probability. So rolling stones or new direction, where 15 plus 10, 25 is 30 out of 40, which of course is 3/4. Likes new direction only. Well, technically over here, this is new direction and not rolling stones. So that's going to be 15 out of 40. And of course, 5 goes into 15, so that's going to be 3/8, isn't it? Neither band, again, if you get the Venn diagram right, a lot of this stuff's very hard to get wrong, but neither band is going to be N, and not R, which is 10 out of 40, which is 1/4. Now let's get to the part that we've been looking at today, conditional probability. Likes new direction, you see that word given, that should be a given that you need to use conditional probability. So what we do is probability that they like new direction. Let's write it out. It would look something like this. New direction given that they like rolling stones. And we could use the formula as we've talked about, but we can say, okay, well, given that they like rolling stones, 15 students like rolling stones. So it's suddenly just out of 15. And of those, 10 like new direction, don't they? I can divide by 5. That's going to be 2/3. And finally, likes the rolling stones, be very careful, given they do not like new direction. Now, the thing is with this one is that they've been given they do not like new direction. Now, these people don't like new direction, do they? No. But is it just out of 5? What's it out of? 15. Okay. They don't like new direction either. So given we're out of 15, how many of those like rolling stones? 5 out of 15. Okay, so it's going to be the probability, and no formula for this as such, the probability that they like new direction, rolling stones, given they do not like new direction. So it's not N. Now, so there's 2 of those. It's not R and not N. So we're looking for those things. Okay, so that's going to be 5 out of 15, which is 1/3. Okay, so that's like a typical sort of test style question. Here's a Venn, or draw a Venn diagram, do a little bit of this, and a lot of the time the conditional probability will be at the end of the question, a lot of the time. And then some students can muck up those. I think tending to get the Venn diagrams are easy, and sometimes the students can really mess up those last parts that given that question. Okay, if you're watching this at home, then feel free to try those questions. Thanks for everyone in class. That was fantastic. And we'll see you next time.